So good day everyone. So my name is Michael J.P. Tiad and today I am going to discuss the Lee Chatelier's principle. So Lee Chatelier's principle is a fundamental concept in chemistry that helps predict how a system at equilibrium responds to changes in conditions. So these conditions may be affected by the temperature, the pressure, or the concentration in a chemical reaction. So developed by French chemist Henri Lee Chatelier in the late 19th century, this provides insight into the dynamic nature of chemical equilibria. So we have key elements of Lee Chatelier's principle. So first definition of equilibrium. So equilibrium in a chemical system refers to a state where the rates of the forward and reverse actions are balanced. So when we say equilibrium, so it is a state of balance between the opposing forces or reactions. So which is at this point, the concentration of reactants and products remain relatively constant over time. It's important to recognize the equilibrium is dynamic reactions continue but in equal phase. So what is dynamic reaction? So example. So, dynamic equilibrium. So, it is a state in which two opposing processes occur at the same rate, resulting in balanced and stable overall systems. It is often applied to chemical reactions where the rates of the forward and reverse are equal, leading to no net change in the concentration of reactant and product over time. So, as we can see here, we have the reactant of the NH2 and the hydrogen atoms which result to ammonia NH3. So we can see different reactions. We have the forward reactions and reverse reactions in the equilibrium. So even though lahi siya reaction, same lang gapon ng iyang result sa iyang chemical reaction. Next is Lee Chatelier's principle statement. So asserts that when a system at equilibrium experiences an eternal influences such as change in temperature, pressure, or concentration or reactants product, so it will respond by adjusting its position to counteract that change. So this implies that the system seeks to restore equilibrium by favoring forward or reverse reaction. So factors influencing equilibrium. So we have A, changes, concentration changes. So if the concentration of reactant or product is altered, the system adjusts to mitigate this change. So it does by shifting the equilibrium positions to either left or right para mabalance siya. So promoting the formation or consumption of certain substances. So this adjustment aims to restore the initial balance and concentrations. So we have B, temperature changes. So changes in temperature influence the equilibrium position. So for exothermic reaction, those releasing heat. So in an increase in temperature, shift equilibriums towards the reactant which is right. So absorbing the excess heat. So conversely, for endothermic reactions, for the absorbing heat increasing in temperature shifts to equilibrium towards the product absorbing additional heat which is going to left. So we have an example here. So we have the N2 plus the hydrogen atoms because NH3 ammonia. So when we say exothermic, so no, gives out heat energy. So pag going siya sa right, which is ang katong iyang product. So when we say endothermic, nag-absorb siya og heat which is going to left. So that's it. Muna siya tong ma-effect sa temperature changes, I mean. In addition to that, so this exists because the equilibrium needs to balance out, so makahelp jud ang temperatures to balance it. Lastly, you have the pressure changes. So this factor is relevant only for reactions involving gases. An increase in pressure leads the system to shift its position to the side with fewer moles of gas. Conversely, a decrease in pressure prompts a shift towards with the side with more moles of gas daw. Since this adjustment helps the system to adjust in its physical environment. So we have an picture here no para mas makasabot mo. So disturbing a system at dynamic equilibrium shift the equilibrium in the direction that counteracts the changes. Kung may mapataas, may mapaubos, so sa'yo na siya masabtan. So ang concentration always na siya constant. So kung ang reactant concentration mo-favors, kumuta siya, mo-favor po siya sa product formation. Ug ang product formation concentration, mo-favor po siya sa reactor formation. So sa temperature, mo ni green sila. So temperature, so mo-favor siya sa endothermic reactions. Kung mapataas ang yung temperature. Ug mubos yung temperature, mo-favor siya sa exothermic reaction. And ang pressure mo, taas ang pressure, favor siya with the fewer molecules like akong gina or katong most i-pressure mo boss, favor siya side with more molecules. So mura na siya dra guys dapit. So dili ra yun siya masabtan guys if you look at this picture. And additional on that, no, so in the equilibrium, we only tend to use the substances that are in their gas or aqueous state, dahil, no? And we never use include solid and kanang liquid. And so let's continue. So sure, let's consider the reaction of N2 plus 3H2 equals ammonia. So this is synthesis of ammonia and H3. Now let's apply the Le-Chatelier's principle to different changes. So let's go. And also dapat balance ang iyang equation, dahil. So we have sample question, no? So for number 1, what happens if you increase the temperature in the ammonia synthesis reaction? So second is, if the pressure is decreased, which direction will the reaction shift? Third one is, if you add more N2 to the system, what happens to the equilibrium? So mura na. So don't mind the answer, kay I'll give you an explanation for that. So for the answer for question number 1 is the what happens, no, in the increase in temperature. So change is heat is added and the shift is reaction to the left, which is the reverse. So the explanation, the reaction favors to the reverse, which is in the thermic siya. Reaction to absorb the added heat, producing more reactants of N2 and H2. So mas masabtan na nimo siya if katong imong gilook up tong akong gipakita na picture earlier. And so for the second question is decrease in pressure. So ang change dito is pressure is reduced or na decrease. So the shift is the reaction shift to the side with more moles of gas. Explanation, so the forward reaction formation of NH3 motong sa N2 plus H2 has fewer moles of gas daw. So a lower pressure favors to the side with more moles, which is katong N2 and H2. As we know, pag gamay ang iyang pressure or nag-decrease, mosayad siya sa mga daghan na moles. So sayo na dyan siya masabtan, guys. And so for the last question, which is the 3, increase in concentration or adding into the system. So we have changed more into is added daw. Shift, reaction shift to the left. Explanation is the system reacts to counteract the increase of N2, no, by favoring the consumption of N2. Kay para mabalance ang iyang system of equilibrium. Kay kung di siya mabalance, so mali igapon siya. So dili ra siya masabtan. So we need to balance thing out para or natay himo na ara to siyang ikatrack kay para mabalance siya. So let's proceed to the final sample questions. So in this question, so we have the reactions or the chemical reactions of H2 plus Cl2 yield to 2HCl. So the first question is, if the temperature decrease, what happens to the equilibrium? And the second one is, what is the effect of the increasing pressure in this reaction? And kung gusto mo maka-answer, then you can pause, then inyo ra siyang i-continue para makatuon pud mo ba. So we have the chemical reaction of the H2 plus Cl2 yield to 2HCl. So we have the question for number 1, decrease in temperature daw. So change temperature is decrease and the shift of the reaction goes to the right, which is the forward reaction. So the explanation is the reaction moves in the direction that releases heat, favoring the formation of product. Syempre kay nag-decrease man yung temperature. So exothermic yun sa jud, guys. So for the last question, so increase in pressure. So ang nagbago dito is pressure is increased daw. And mo shift siya sa side na naay fewer moles of gas kay na-increase man ang iyang pressure. Like makabalo mo to, like katong ang gipakita gina illustration or katong picture gaina. Sa explanation is the forward reactions, which is the formation of H2 plus Cl yield to 2HCl has fewer moles of gas. So ang iyang product is gamay ra daw or few na siya pure moles. So an increase in pressure favors to the side with fewer moles, which is katong iyang product. So that's it, guys. Sayo na kay siya sabton. So that will be all, guys. Thank you.